And welcome everybody to the Daily Space Weather. Today we'll be talking about a possible coronal mass ejection unfolding as we stream the video live. Also some occultation. Has the sun turned into a death device? Field-aligned currents, fewer galaxies, occultation, and more. I'm your host Dan, aka smAsho. Let's start things out by looking at the sun. And it seems that the sun has developed a Death Star-like magnetic appendage up here in the northwest. Is it because we're all going to die? Nope. It's because the sun is being occulted by the moon. You can see a little bit of lunar occultation happening. Let me just refresh that. Some lunar occultation happening there of the SDO, and that's causing issues with the magnetometer data in that area, making it look like magnetic fields appearing where they aren't. So here you can see some occultation in 304 angstroms as well. I better refresh that one too. And so if indeed we are seeing a coronal mass ejection, my best guess is that it's from this filament right here. It may be in the process of exiting the corona as we made the video. And we'll show you more views, some close-ups, as well as the view from Lagrange point 5 here where stereo A is located. So here's the coronagraph from stereo A, and you can see this building region right here. You see right there at the end, you see it brightening up, an indication that it's entirely possible that it may be about to eject. We'll have to keep an eye on that. And when I say ion, well, the pun is intentional. So again, that's the viewpoint from stereo A there, located down there at Lagrange point 5, trailing the Earth, orbitally speaking. The radial flux of the outer corona in the 2800 megahertz variety, also known as 10.7 centimeters, is still at 73. And there is the one-year chart of that. And you can see at the last peak of solar activity here, a couple of months ago, we actually made it all the way up into the 100 and teens. And for you new viewers, the radial flux is proportional to sunspot number. So there we've displayed both of those through the last solar cycle on the screen, sunspot number and radial flux. And next we've got some great HelioViewer movies. Let's take a look at the fields real quick. And there's the field situation, no sunspots currently on the solar disk. Here's the fade between 171 and 304 angstroms. So here's a full one-day video, and you can see the moon moving in between the sun and the SDO there. And here it is in 193 angstroms. Major coronal hole associated with the south solar polar region, as well as some north-oriented coronal holes right up here. So we're expecting a wind stream from this coronal hole in about 3 days. And that 193 angstrom view gives us a great view of coronal holes. It's one of the ionized emissive spectral states of ionized iron. And here's the 171 angstroms view as well. We'll save the close-ups till the end of the video. And we'll move on to our Smash Lights segment, where we do a little self-promotion. And we invite you to study cosmology and so on, and visit us on other social media. So here's today's Smash Lights segment. This will be only included in the Daily Space Weather video. We are streaming live to Twitch. It's twitch.tv/smAshomash, a fantastic streaming platform. Also, check out our own websites, smAshomash.org, smAshomash.com. You'll find our social media links there, as well as links to the smAsho forum and the stores. So pick up some merch. Help support the channel that way. If you need some gear, it's pretty sweet. Also, don't forget to press like and subscribe on YouTube. We've also got playlists over there, youtube.com/smAshomash/playlists. There are a bunch of them, and we've got to revamp one of our videos because it got taken down because of alleged medical misinformation. You can still find it on BitChute, bitchute.com/smAshomash. It's the Smash News Network special report, Smash Hole of the Week, episode 00001, COVIDiots. If you haven't watched it, give it a look. We'll have to redo it to make it appropriate for YouTube and not get banned. So today's cosmology segment should be interesting. We've got a couple of different things to talk about regarding cosmology, and we incorporate these into the Daily Space Weather video because here at SNN, Least Busted Name in News, the Smash News Network, we realize that the sun is the Rosetta Stone of all cosmology. So, energy from the solar wind favors the north. Were you aware of the way the field-aligned currents operate? Well, it must have something to do with polarity, I would say, as the majority of the solar wind is indeed hydrogen nuclei, which are positively charged particles. And for some reason or another, they favor the north, and we see this regularly. We showed geospace magnetosphere movies regularly on the channel. Here's a little clip from the ESA's YouTube video talking about what the Earth's magnetic field is generated from. And a lot of people believe it's like a bar magnet. I believe it's two dipole magnets, but in any case, perhaps read this article on phys.org's Space and Astronomy section, talking about things like Alphen waves and the way the auroras behave differently. So that's interesting. Why is it that solar energy favors the North Pole? Is it because of polarity, or does it tell us something about Earth's internal structures that may be even more important than the relationship between field-aligned currents and incoming solar protons? Next, I'd like to thank our patrons, the true source of funding for the content. Before we continue with the cosmology segment, thanks, patrons. Please consider becoming a patron and supporting the channel that way, as it is, again, the true source of funding for the content. Patreon.com/smAshomash. We need your assistance to continue on achieving our goals in the year 2021. And we'll give you all kinds of perks. Today we're not going to roll any dice. We're going to look at the X-ray transient outbursts from the core of the Milky Way galaxy, known as Sagittarius A star. And we saw a recent uptick here over the past about 7 days. 1 week of increased activity coming from the core of the Milky Way galaxy in the frequency of X-ray. And there you can see that 30-day graph in the lower left. In the upper right, that's the historic graph of X-ray flux from Sagittarius A star, the massive radio source at the core of the Milky Way galaxy, going back to about 2004. Next, we'll talk about Zodiacal Dust. Turns out there may be a lot fewer galaxies than previously thought. The New Horizons spacecraft did some measurements of the light coming out of the background of deep space and discovered that there are probably only hundreds of billions of galaxies instead of 2 trillions. So that's a thing for cosmology. And the New Horizons spacecraft way out by Pluto and the Kuiper Belt. And it's easier to measure this in deep space than it is in the earthly portion of the solar system because of that zodiacal dust, which reflects a bunch of light and makes it more difficult to estimate how many galaxies may be out there. This one is on SciTech Daily. I'm sure it'll be all over the Science Wire. Let's see if there's a paper also. No paper linked here, but it is on SciTech Daily. SciTechDaily.com, one of my favorite news sources. Now, Robitaille has put up another video here talking about lattice confinement reactions in the sun. And I'm going to play an important little clip here from this. Make sure it's loud enough for you to hear. Because Robitaille believes that all stars are capable of making all of the elements. So here's a little clip.
I believe that these experiments and others like them will eventually help to clarify that the stars can make all the elements.
So this is an important distinction to understand when it comes to things like cosmology. The possibility that we don't need supernoval explosions, fusion dynamos inside of stars, etc., to create all the heavy elements. What if they're happening right in plain view on the surface of stars? Now, I haven't watched this full video yet, but this is a great example of the way Robitaille will correct himself and update his information when he is wrong or when new information is brought to his attention. So we encourage all of our viewers to do the same, as that is how you have things called integrity, a lack of an agenda, and the ability to adapt. As if you are ossified in your beliefs, you're not doing science, you're doing dogma. So check out Robitaille's latest video here. It's on the Sky Scholar channel. Only at 28,000 subscribers, and they don't need our help because we're hardly at 1,700 subscribers. And that's today's Cosmology segment. Please tell your friends, foes, science noobs, and science pros about the channel. And thanks to all of our viewers, new viewers, old viewers, those who have been viewing our videos all the way back to when we were doing fake news weather reports just to sort of test the waters on YouTube. Let's get to more data, like the real-time solar wind, which remains slightly elevated here at about 426 kilometers per second. Solar wind density has moved back to more or less background levels here at 5.3 protons per cubic centimeter. And we've seen recent shifts here in the BTBZ. So this could be a result of plasma ejecting the last couple hours there. That could be a result of a coronal mass ejection. You can see the BT shifting. Well, the BT is pretty consistent there, around 6. And that's nanotesla. And the BZ has shifted significantly here from 2 to -2. So this is something we do see typically at times of coronal mass ejections, more of an indication that there is one happening as we made the video. KP index has been pegged at 1 for the past 27 hours. And you can see that period of geomagnetic unrest yesterday. Next, looking at 4 hours of data here, it's a magnetosphere movie. Pretty steady solar wind situation here. Not a lot of changes in that. The main pressure is in the magnetotail region. I think I might have seen some missing data there. And we do have about an hour and 15 minutes of missing data. You can see it goes from 8:14 to 9:34. And next we'll look at ground magnetic perturbations, since there is a geomagnetic excursion happening. And this is showing changes in the Earth's B field, hence the reference delta B. When you see delta in science, that means change in this case, changes in the Earth's B field. And we'll show you the sun's B field momentarily. I'll let that play through a second time there to show ground magnetic perturbations. We don't see any proton strikes. No coronal mass ejections have struck the magnetosphere significantly in the past several weeks. And we don't see any solar flares either. There's the 3-day chart of the X-ray flux. We see low readings here in the GOES magnetometers. And that's because there is a large filament between the sun and the Earth right now. The next frame will show it. And this filament right here, The arrow will be pointing at it right there. That's what's causing those low magnetometer readings. And that filament may be in the process of ejecting now. So the Earth's still solidly in the South Pole oriented current sheet shown there in red. No surprises there. We forecasted it yesterday. Just keep in mind the data is an hour and a half old, and the magnetic environment can suddenly change. So for instance, if that plasma ejects and it's not earthly facing, you'll see sudden changes in the GOES magnetometer from that. As the plasma has the ability to block the measurement of the magnetic fields, as well as being heated up and oriented to said fields. So this one's showing you the sun's B field here in blue. We can also see that large South Pole oriented coronal hole in red, and that large North Pole oriented coronal hole system in green, just south of the solar pole. And here's another view of essentially the same data. It also shows you the solar magnetogram. Nothing exciting there really going on. And here's a diagram of the solar corona, the sun's atmosphere. And again, there are large filaments in between the sun and the earth right now. Here's a sky chart. I'm always interested in what's going on over my head. Today the sun will pass through Libra and Virgo and Leo and Gemini, and then everybody will be scared and spooked when it sets in Taurus. Here's what's going on in the solar system. And here's me checking the life of the stream. And again, thanks to everybody who viewed the video, whether you viewed it live or you viewed it at the live premiere or you viewed it in syndication. Cheers. Here's what's going on in the solar system. There's where things will be in a week, and happy new moon day. And it looks like Frito-Lay is maintaining its stranglehold on the solar system. And as we all know, shapes in space are very, very scary. When you see a triangle, be scared. Be very scared. Let's talk electrons. We don't see any charging hazards when it comes to satellite charging. That's what we're looking at right here. And we see low levels of electron flux, with a forecast for an increase to more moderate levels here by NOAA. I have no reason to refute that. And there's a 3-day chart of the GOES electron flux as measured by the GOES 16 at the F ionosphere layer. And there's where the F ionosphere is located. It's at about 300 kilometers altitude. Next, we'll look at the electron flux visualization. And you're basically looking at a visualization of the inner Van Allen belt here. This will give you an idea where GPS errors would occur. Nothing too exciting happening there. And there you can see the things like altitudes of GPS satellites at 12,500 miles, the location of the low Earth orbit of the International Space Station at about 230 miles. Check it out, we got some power outages here. Over 350,000 power outages in Washington reported, and another 63,000 reported in Oregon. What is causing that? Is it inclement weather? Let us know in the comments if you have any idea. Next, looking at the ionosphere. And this is a full day of data provided by Australian Government Bureau of Meteorology. And we're seeing an anomalous ionosphere here. I don't know how else to explain it. If you don't look at it daily, you may not understand. Yet another reason to watch our videos every day. As if you don't immerse yourself in the data, you may not understand it. It's part of the reason why we made a channel in the first place, because we were disappointed at other space weather coverage. So, when you want something done right, do it yourself. Here's the latest image. And you can see this tripled up set of charge regions in the ionosphere. That is not normal. That image is from 9:15 Universal Time. And we see volcanic upticks happening. Kilauea continuing to erupt. Let's see what else is on the list. Well, indeed, Klyuchevskoye is. It's producing a 23,000-foot ash plume. Abiko, 8,000-foot ash plume there. Sakurajima, also erupting, 6,000-foot ash plume as it explodes. Suwanosejima, flight level 060, it's a 6,000-foot ash plume. Dakono exploding, flight level 070, 7,000-foot ash plume. And Kilauea, we've got fountaining and spattering, and we've got a lava lake, which is 643 feet deep. And an outflow channel coming out of the, I believe it's the southwestern Kilauea vent there. Halea'uma'u crater. Popocatépetl also exploding. Flight level 190. Fuego exploding, flight level 140. Revenador exploding, flight level 150. And continuous ash emissions from Sabancaya are an indication not to pole vault the caldera. It could have an unfortunate health result, as we don't want to provide medical misinformation on the channel. Next, looking at earthquakes over the past 24. And we do see one off the coast of Petralia, California. We won't really worry about it, as we don't see any large quakes, but a couple deep ones, such as this 4.9 at Chile, followed about 40 minutes later by a 4.6 at Indonesia. So a couple of deep quakes. Here's one at Wallace and Futuna at over 440 kilometers depth. And the 7, 8, and 9 magnitude earthquake drought continues, folks. Another deep quake at Fiji, a 4.5 magnitude at 559 kilometers. Here's a 5.2 at Greece. That's one of the largest of the past 24. Not the most common spot for an earthquake there. Here's one at the Mogue Islands, which is at a quite desolate spot there in the West Pacific. That 4.7 magnitude at 194 kilometers depth. Another deep quake near Fiji, in the deep quake capital of the world, the Fiji-Tonga region, north of New Zealand. And let's continue on to look at the jet stream. Here are the jets of the Western world. And we see some essentially backwards jet stream flow here over northern South America. The jet stream normally flows west to east, folks. An extreme meridional jet stream flow. The jet stream's all broken up here over the eastern U.S. We see warm air being injected into Greenland, and very cold air being sent into the UK. I didn't mean to put that line there. We see Arctic air being sent into the North Sea there. Here are the jets of the eastern world. And those 250 hectopascal winds are a little bit more organized. A major kink there in southeastern Australia region, as well as some eddies here in the southern hemisphere. A little bit of meridional jet stream flow down there as well. And let's see where lightning's been striking. Mainly the Gulf of Mexico. That's the NASA GOES 16 lightning mapper. Here's a real-time lightning map. I like to use lightningmaps.org. And let me just check the life of the stream once again as that loads. And don't forget to share the video on your social media. Tell your friends, foes, science noobs, and science pros. Anyway, there's the current situation of lightning. No terrestrial lightning in the U.S. to give out any warnings. And here is the U.S. Doppler radar map. We see some wintry mix here, possibly ice storms in South Dakota and Minnesota, as well as in Mississippi. Let us know if you've got some sleet, freezing rain, etc. falling in Mississippi. And are these power outages in Washington and Oregon caused by rain and thunderstorms, as they've been getting heavy precipitation for an extended period in the Pacific Northwest. Next, let's look at pressure cells. I'm going to shrink this down. And this is windy.com. They've got a great mobile app, by the way, if you haven't checked it out, windy.com. And we see a whole series of low pressures here all around the northern Pacific, stretching all the way over to Iceland. Just nothing but low pressures. Western U.S. dominated by high pressure. And we'll just move this forward to see where the there's the GFS forecast. There's where the GFS forecast puts pressure cells at noon tomorrow. And we are talking local time. SMASH staff and I are located in Lehigh Valley, Pennsylvania. Next, looking at the cloud layer over the U.S. And I see a slight counterclockwise rotation there over northern Louisiana, as there is a weak low pressure system in there. And it's all being surrounded by a bunch of dry, massive air that you can see. And that dry, massive air is a characteristic of clear skies. So when in doubt, looking at your Doppler radar, perhaps use the NASA GOES interactive weather satellite water vapor, as water vapor not even condensed onto a cloud can't hide from that satellite. Lots of low clouds over the Gulf of Mexico and the Atlantic Ocean as well. You can see them in that image. And it's time for bonus features. We're going to show you the full res image of the sun in Colorized Magnetogram to show you the 0 sunspots. A little bit of magnetic organization happening in the southern hemisphere, a heap and helping of nothing happening in the northern hemisphere. Some slightly organized spots there, active regions, doesn't look like any sunspots to me. And there's the intensitygram. No sunspots, no umbrae to be seen today. And let's show the final HelioViewer movies, as we've got some close-ups. We're going to show you the North Solar Polar Field region in 193 angstroms to show that lunar occultation of the SDO, as well as the rotating in coronal hole area. Here's me vanishing. So great view of that lunar occultation as well. See that slide across. Here's the South Solar Polar region. And that is a large coronal hole. You can also see that filament, which may be in the process of erupting in the lower left of your screen. Great view of that coronal hole especially. Next, a close-up of that filament in 171 angstroms. And if I had to guess, I would think that that is probably erupting. It looks quite turbulent there. And last but not least, here is the same view in 304 angstroms. The ionized helium view of 304 angstroms will give you added insight into the three-dimensionality of that filament. And now it's time to close this thing out. Thanks for tuning in. Don't forget to share the content on your social media. Tell your friends and foes about the channel. As we haven't even begun to create content yet. This is barely even the ground level. Visit our websites. Become a patron. Press like and subscribe. Remember to stare at the sun. Welcome to the Neo-Renaissance, and may that solar wind be at your back.